Hello everyone. Many thanks for checking my website. My name is Ali Yassin and I'm currently a professor of engineering management at AUB, the American University of Beirut, in Beirut, Lebanon. Product development in the 21st century involves the development of large, multidisciplinary, distributed and networked systems that cannot be embraced by a single group or organization. Traditionally, the technical complexity of these complex systems have been addressed through decomposition. In decomposition, the overall system is decomposed into subsystems or modules according to a specified architecture that allows us to deal with each subsystem individually. So, what is the proper decomposition? What is the optimal product architecture? Modular architecture with few well-defined interfaces versus an integral architecture with more complex interfaces. Which one do we select? How do we choose an architecture that can easily accommodate future technologies and evolving customer needs? That's another important question. How to choose architectures that are robust against failures and attacks? How do products evolve considering a specific architecture? All these are important questions that need to be addressed. My research tries to address many of these questions using the design structure matrix method, which is a technique that I have pioneered over the last 20 years. Here we look at a DSM, a product DSM, that has several elements. So the row and column headings are the names of these subsystems, and the up-diagonal marks represent the relationship if there exists a relationship between these various elements. System elements are clustered or grouped into modules such that the interactions within each module are maximized and interactions between modules are eliminated or minimized. I have experimented with various clustering techniques using optimization theory, genetic algorithms, and machine learning techniques. To complicate things further, these modules are assigned to various development teams. As I said earlier, decomposition addresses the technical complexity of product development. However, it opens a whole new set of managerial problems and challenges due to these interdependencies and interfaces between the subsystems and modules. These teams can have their own social network, which may or may not be reflected or represented in a formal organizational chart. My research tries to understand from the social network perspective which players are the most prominent in terms of supplying or receiving information and which are not. Then, and most importantly, we would like to know if the social network support the required communication patterns and coordination mechanisms for a specific decomposition or product architecture. So, do we design the organization and then the product, or vice versa? Do products look like organizations that make them, or vice versa? Or do they co-evolve? Changes in product architecture may conflict with rigidities in organizational structures, communication patterns, and coordination mechanisms. To complicate things even further, we have the process domain or the project management view. The project schedule is not your usual schedule used in critical path method or PERT techniques. Those traditional project management techniques, there can be repetitions of upstream activities or iteration as you learn more downstream, such as downstream testing activities. You might revisit earlier design decisions. Activities can also overlap based on preliminary information exchanges or sharing. My research assesses the impact of rework and overlapping on project duration and cost and performance, obviously. Does the social network supports the required preliminary partial information exchanges or flows because some people fear to share partial information? not to be blamed later for it being changed. Also, does the partial information flows or rework cross module boundaries as specified by the chosen architecture? All of these are important questions that need to be addressed when figuring out what is the proper product architecture and when trying to figure out what is the duration of a particular development project. So my research deals with understanding and modeling each domain individually, and then building models that tie together all these three domains together. Dependencies and information flow is the key to gluing these three domains together. Well, thank you. This concludes my presentation. Thank you for watching. I'm ready to answer any questions that you may have. Please do email me at ali.yassin@gmail.com or ali.yassin@eb.edu.lb. Thank you very much.